Hi guys, welcome to the video. So I'm gonna do some problems that are on this review. So I'm gonna skip through a few of them, and then there's gonna be another part to this video that does the rest of the problems. Alright, so let's start off on number 1. So we got 4 times 2x minus 3 equals 2x plus 3. Alright, so we're solving for x, so we have to start off by distributing this 4. That's going to give us 8x minus, let me do that again. So we got 8x minus 12 equals 2x plus 3. Alright, so let's get the x's on one side, the constants on the other. Alright, so I could add 12 here. Alright, so we got 8x equals 2x plus 15. Now I could subtract the 2x. That's going to give us 6x equals 15. And then last thing I'm going to do is divide by 6. Alright, so we end up with x equals 15 over 6, which reduces to 15 and 6 can both reduce by a factor of 3, so that's going to give us 5 over 2. Alright, so now let's go to the next one. And again, the other problems are going to be on the next part of this video. Let's go to 20 and 21. So we have y equals the absolute value of x minus 3. Right, since we have minus 3 inside the absolute value, that's going to be a transformation of right 3. Right, so let's, and also the vertex would be at 3, 0. Alright, so the h and k is 3, 0. And then if you want to graph this on the calculator, you can go to y equals, type in math num abs to get the absolute value, x minus 3. Right, and then you can get the points off the table. So we got 4, 1, 2, 1, 5, 2, 1, 2. Right, the domain for absolute values are always negative infinity to infinity. And then for the range represents the y value. Right, so domain was the x, range is the y. The y values start at 0 and then keep going up to infinity. So bracket 0, infinity. Right, then for 21, we have a transformation of down 3. Right, so the vertex would be at 0, negative 3. Right, and again, you could just plug this into the calculator to get the points. So we got math num abs x, then on the outside minus 3. Go to the table, and then you can get the points. Right, then domain, that would be negative infinity to infinity. And then for the range, we start at negative 3 for the y's, and then they keep going up to infinity. Right, then for number 42, this one's going to be a factoring problem. Alright, so we're going to split the middle term. So we start off by multiplying a times c. That's going to give us negative 20. And then the middle term's a 1. So two numbers that multiply to negative 20 add up to 1. that would be 5 times negative 4. 5 minus 4 is 1. So we're going to use these two numbers to split the middle term. Always think ahead when you split the middle. I'm going to put the negative 4x first, then plus 5x minus 10. Then take out a GCF from each side. So on the left side I could take out a 2x. If I divide these by 2x, we get 1x minus 2. On the right side we could take out a 5. If I divide these by 5, we get x minus 2 as well. Since these two are the same, that means we did the factoring correctly by splitting the middle term. Now whatever you took out from each side, combine them or put them together. So we got 2x plus 5 for one of the factors. Then the one that they both shared, that's the other one. Alright, then we got number 45 next. This is going to be a dots. Alright, so we got two perfect squares separated with a minus. So make your two sets of parentheses, one with a plus, one with a minus. If you were to square root the x squared, you would get x and x. If you were to square root 36, that would be 6. So x plus 6, x minus 6. And again, this is a dots. Alright, and then again, the next part will be the rest of the problems on another section of this video. Alright, so let's get started off on number 1. It says, given f of x equals x squared minus 5 and g of x equals 3x plus 12, find. Alright, so A says find f of negative 4. Alright, so this is telling us that x is negative 4 and we got to find what the y value is when x is negative 4. So the function f is this one right here. So we got f of negative 4 equals negative 4 squared minus 5. Alright, also be careful when you square a negative. There's a difference between doing negative 4 squared like this and a difference when you put it in parentheses. The correct way is putting the negative 4 in a parentheses, then squaring it, and you get positive 16. Alright, so we end up with f of negative 4 is 11. Right, now for g of x, g of negative 9, we're going to use g of x, that's the function g, and we're trying to find what g of x is when x is negative 9. Alright, so we got 3 times negative 9 plus 12. Alright, 3 times negative 9, that's negative 27 plus 12. That's going to be negative 15. Then f of 0, we got 0 squared minus 5, which is just negative 5. Right, then for 2, 3, and 4, it says state whether each relation is a function or not, state the domain and range, use set builder notation. Alright, so for these maps, ordered pairs, or tables, if they're going to be a function, every x value should have one unique y value. Alright, here we have a 3, it has one y value. Here this 2 has two different y values. Alright, so because this 2 has two different y values, it makes it not a function. And then for the domain, all we have to do is just list out the set of x's and list out the set of y's for the range. Alright, so for the domain, this would represent the x, so we got negative 1, 2, and 3. And then for the range, we got 1, 3, 5, and 7. Right, so now on number 3, same thing. We have an x value that has two different y values. We have 0.5 has a y value of -3, and 0.5 also has a y value of 8. So that makes this not a function. And then for the domain, we just have 0.5 and 2. And then for the range, we have -3, 0.8, and 8. Alright, now for number 4. When x is 4, it has a y value of 5. When x is 6, it has a y value of 5. Also, when x is 3, it has a y value of 5. So each of these x values only has one y value, so it does make it a function. And so here, if we saw a map of it, it would just be 5. Here, I guess I should have put the 3 first. 3 and 6. Right, they all go to 1y, which is okay. If one of these x's had a different y, then it would have made it not a function. And then for the domain, we got 3, 4, and 6 for the x's, and then for the range, it's just 5. Right, then for number 5, if a graph consisted of points not connected, then how would the domain and range be written? It would just be written as a set. So if it's just points and they're not connected, you would just write them as a set. So just list out the x values for the domain, and then for the range, just list out the y values. Alright, then for number 6, determine whether the following scatter plot has a positive correlation or a negative correlation or no correlation. Alright, so number 6, we have all the points kind of scattered everywhere, so this is obviously going to be a no correlation. Here on 7, as the x values are getting bigger, the y values are also increasing, so this is going to be a positive correlation. And then for this one, as my x values increase, my y values are decreasing, so this is going to be a negative correlation. And also you can just tell by the trend lines. Right, so number 9, the function y equals -x plus 10.5 was to fit the scatter plot shown. Which of the following would create a better trend line? Right, so if we decrease the slope, it's just going to make the line kind of just go this way. So it's not really going to fit the trend. It's going to move more this way. If we decrease the y-intercept by 2 points, it's going to bring the whole line. So all the y values would just come down too, which would probably be better. And then if you increase the slope by 1, it's just going to be a little bit more positive. And then increase the y-intercept by 12. If we increase the y-intercept by 12, it's going to be like off the graph. So this one, the best choice is just decrease the y value or the y-intercept by 2 points, and it'll bring the line a little bit more down to fit this trend or these dots or the points. All right. So then for number 10, solve by graphing y equals -x plus 4. All right. We have a y-intercept of 4. Slope is -1, so we're going to go down 1, right 1. Right. Alright, then here we have a y-intercept of -2, and the slope is 1/2. So we're going to go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And then here we could see the intersection. Right, so here we could see that both lines intersect at the point 4, 0. Right, then for number 11, if we want to graph these, they have to be in slope-intercept form. So the first one's good, but the second one we have to subtract the 3x. So we get y equals -3x plus 1. Alright, so I'm going to start off by graphing this one. It has a y-intercept of 5, slope of 1. So we just go up 1, right 1. Right, now for this one, it has a y-intercept of +1, and we're going to go down 3, right 1, since the slope is -3. So rise, or go down 1, 2, 3, right 1, 2, 3, right 1. And here we could see that they both intersect at -1, -1, 4. Alright, then for 12 and 13 it says solve by substitution. Alright, since this second equation equals x, I could substitute this equation in for x in the first one. So the way this looks, it would look like this. So 3 parentheses 8y minus 10, since that equals x, plus 9y equals 36. Right, so now let's solve for y. So I'm going to start off by distributing this 3. We get 24y minus 30 plus 9y equals 36. I'm going to combine my like terms. 24 plus 9y is 33. Then I'm going to add the 30. We get 66. And then when I divide by 33, we get y equals 2. Alright, so we found the y, now we got to find the x. So just plug this 2, y equals 2, into this second equation, and it's going to help us find the x. Alright, so let's do that real quick. So x equals 8 times 2 minus 10. That is x equals 16 minus 10, which is x equals 6. So the solution on 12 would be 6, 2. Alright, same thing on 13, but this time we have y equals x plus 2. So this x plus 2 can replace anything with a y in the first equation. So this is going to be set up as x plus 2 parentheses x plus 2 equals -5. Since we have a 2 outside the parentheses, I'm going to distribute that into the x plus 2. So we get x plus 2x plus 4 equals -5. Combine your like terms, we get 3x plus 4 equals -5. Subtract the 4, we get 3x equals -9. Then divide the 3, x equals -3. Now we're going to use this -3 to find the y. So we know y equals x plus 2. We know what x is, it's -3. So this is just y equals -3 plus 2, which is -1. So our solution here is -3, -1. Alright, so that was substitution. Now let's go to linear elimination. Alright, so with elimination, you want them to both be in standard form, and then you want to decide which variable you want to get rid of. So here you could get rid of the x, or could get rid of the y. For this one, I'm going to let's get rid of the y value. So if I want to get rid of the y value, you know what, for this one, let's get rid of the x. It doesn't matter which one you get rid of. I'm just going to do the x real quick. So if I want to get rid of this x, since I have a 2x here, I have to make this a negative 2x. So if I'm going to make that a negative 2x, I have to multiply this whole row by negative 2. When I multiply this by negative 2, we get negative 2x minus 4y equals negative 12. Alright, so the x's eliminate. We got y, 1y minus 4y, which is negative 3y. 9 minus 12, that's negative 3. Divide by negative 3, we end up with y equals positive 1. And so now we got to use this to find the x. So I'm going to plug this one into the first equation. So we have x plus 2 times 1 equals 6. 2 times 1 is just 2. Subtract the 2, we get x equals 4. So the solution here is 4, 1. Right, now same thing on 15, we have to decide which one we want to get rid of. For this one, we'll get rid of the y's. Here I have a 5y, here I have a negative 2y. So if I want these to be the same with different signs, let's multiply the first row by 2, multiply the second row by 5. Alright, so when I multiply the first row by 2, we end up with 8x plus 10y equals 14. Second row is 15x minus 10y equals, let's see, 34 times 5, that's 170. Alright, so here the y's eliminate. 8x plus 15x, that would be 23x. 14 plus 170 would be 184. And then let's divide 184 by 23, which is 8. Alright, so we got x equals 8. Now let's use this x to find a y value from one of the original equations. So we got, here let's use the second one. 3 times 8 minus 2y equals 34. 3 times 8, that's 24. Let's subtract the 24. At 34 minus 24 is just 10. Divide by negative 2, we get y equals negative 5. So we got our x, we got our y, so the solution here would be 8, negative 5. Alright, so then for 16 and 17, solve using matrices. Write the augmented matrix for each, then solve in the calculator. Write the solution as an ordered triple. Alright, so let's write this as an augmented matrix first. Alright, so the first row is just 5, negative 1, 3, 5, 2, 7, negative 2, 5, 4, negative 5, negative 7, negative 65. Alright, so now let's solve that using the calculator. So second matrix, edit, make sure I have a 3 by 4. Alright, so I made my matrix, then I'm going to go back to the normal screen, so second quit, go back to second matrix, go to math, and go to reduce row echelon form, so RREF, then go back to second matrix, insert matrix A, which is the one that we made, and then we get this solution matrix. Alright, so this matrix, the solution one is telling us 1, 0, 0, 0, negative 2, 0, 1, 0, 3, 0, 0, 1, 6. Alright, so our ordered triple is negative 2, 3, and 6. That's our X, Y, and Z. Alright, so same thing on 17. Let's make the augmented matrix first. Alright, so then second matrix, edit. Alright, then second matrix, so go back to the normal screen, second matrix, REF, second matrix, enter matrix A, and then we get, for the solution matrix, 1, 0, 0, negative 0.5, 0, 1, 0, 1, 0, 0, 1, 6. Alright, so we got negative 0.5, comma 1, comma 6 for our solutions. Alright, then for number 18, Rob bought 15 concert tickets worth $322.50. Floor tickets cost $25 each, while balcony tickets cost $17.50 each. How many tickets of each type did Rob buy? So first it says identify the variables to be used. Alright, so let's just use F for floor tickets. Yeah. So we got F for floor tickets, and B is number of balcony tickets. And so this should have been number of floor tickets. Alright, so write and solve a system of equations to determine the number of each type of ticket. Alright, so we got 15 tickets were bought and they were worth $32.50. So together, floor tickets plus balcony tickets, he bought 15 total. So F plus B equals 15. Alright, since the floor tickets cost 25, that would be 25F. Balcony tickets plus 17.50B, and the cost was 32.50. Alright, so I could use elimination or I could use substitution. For this one, let's use substitution. So let's try to find the, so for this one, let's solve for F. So F equals negative B plus 15. Alright, so I'm going to use substitution. Anything with an F, I'm going to replace it with negative B plus 15. So we got 25, negative B plus 15, plus 17.50B equals 32.50. Distribute the 25, we got negative 25B. We got 15 times 25, that's 375. Plus 17.50B. Alright, combine my like terms. Alright, so we got negative 7.5B. I'm going to subtract the 375. Alright, so we got negative 7.5B equals negative 52.5. So I'm going to divide the negative 7.5 now. And we get B equals 7. Alright, so we got 7 tickets for balconies, so that means F plus 7 equals 15. So the amount of floor tickets, if I subtract the 7, that would be 8. So we got 8 floor tickets and 7 balcony tickets. Also, another method you could have used on this one, you could have set up a matrix with this and then just done RREF. So that's another way you could have done that. Alright, so then for number 19, graph, state the transformations, state the domain and range using interval notation. Alright, so these are quadratic equations or quadratic functions. So always start off with the vertex first. So -3, -2. Alright, then let's get the rest of the points using the calculator. So again, you have a calculator on the test, so let's use that. -2 parentheses x plus 3, don't forget the squared, minus 2. Alright, let's locate the vertex that we had. Oh, let me fix this. There we go. So we got -3, -2, then we got -4, -4. And we got -2, -4. And then we got -1, -10. And we had -5, -10. Right, now for the transformations, we could see from the graph we had a reflection over the x. We got a vertical expansion by 2. We got a shift left 3. And we're going vertical shift down 2. Right, domain should always be -∞, infinity for these quadratic or these parabolas, and then for the range, since the graph is upside down, we start with -∞, and bottom up on the y-axis it stops at -2. Alright, so then same thing on 20. Let's locate the vertex first. So we have h but no k, so 4, 0. Alright, so 4, 0. Now let's plug this into the calculator. Alright, so we got a half, which is the same as 0.5. X minus 4 squared. Go to the table. Let's locate our vertex. It's 4, 0. And then I'm just going to put the points that actually fit on the graph. So we got 2, 2. Then we got 6, 2. Let's see what else. We got 8, 8. And so that means there should be an 8 over here also. So 0, 8. And then those should be the ones that fit on the graph. So let's draw the parabola. Alright, so for the transformations, we have a half for the A value, so that's a vertical compression by 1/2. And the graph is going to shift right 4. Right, domain, all real numbers, -∞ to infinity. Right, for the range, we start at 0 and then it keeps going up to infinity. So remember, the range is the y's, the domain are the x. Alright, then for 21, 22, it's the same thing, but this time we got absolute value functions. Alright, so those make the V shape, but the vertex could still be found the same way, just h and k. This would be 1, 4. And so here, let's do the transformations real quick. We have a reflection over the x. It's going to shift right 1 and up 4. Alright, then reminder, to get an absolute value on the calculator, you do math num abs. Alright, so then let's locate the vertex first. We got 1, 4, and then we got points at 0, 3, and 2, 3. Alright, let's get a couple more points. We got 3, 2, and negative 1, 2. And then here, I guess we'll do one more. Negative 2, 1. And 4, 1. Alright, so the domain, it's always going to be going this way, always going to be going this way, so it's negative infinity to infinity. And then for the range, it's upside down, so we start with negative infinity, and then on the y-axis, it stops at positive 4. Alright, so same thing on 22. Here we have a vertical expansion by 2. We have a shift left 3, and it's going to go down 1. Alright, so the vertex would be at negative 3, negative 1. Alright, so let's find some points. Alright, so locate my vertex, negative 3, negative 1, and then let's get a couple points. So negative 4, 1, negative 2, 1. So negative 4, 1, negative 2, 1. Alright, then we got another point at negative 1, 3, negative 5, 3. And then we also got 0, 5, negative 6, 5. Alright, so domain, still negative infinity to infinity. And then range would be from negative 1 to infinity. Oh, shoot. Alright, so this is 22, vertical expansion by 2, left 3, down 1, negative infinity to infinity, negative 1 to infinity for the range. Alright, now for 23, we're going to continue with absolute values, but this time we're going to solve them. So remember, with absolute values, there's two scenarios, a positive scenario and a negative scenario. So here we got positive 3x minus 9 equals 6, negative parentheses 3x minus 9 equals 6. Alright, so for the first one, let's solve for x. So 3x equals 15, divide by 3, x equals 5. For this one, you have to distribute your negative. Alright, subtract 9, we get negative 3 equals negative 3. Divide by negative 3, x equals 1. So our solution set is 1 and 5. Right, now for 24, first thing we have to do is isolate the absolute value. So on 23 it was already isolated. On this one, we have to isolate it by itself, so we have to move the minus 6 and the 5. So first, let's add 6 to both sides. Now divide by 5. Alright, so now we got the absolute value by itself, so now let's make our two scenarios. We got 2x equals 6, negative 2x equals 6. Divide by positive 2, you get 3. Divide by negative 2, we get x equals negative 3. Alright, so that's our solution set. Negative 3 and 3. Alright, then for 25 and 26, same thing, but now we have inequalities. So again, make your two scenarios. And I'm going to go ahead and just make this negative already. Alright, so here just in case y'all don't see it. Alright, so negative distributed to the negative, and then for the first one, subtract 5, we get 6, divide by 2, we get 3. So x is greater than 3. For the second one, add 5, so we get 16, divide by negative 2. Alright, so when you divide by a negative, the sign flips. 16 divided by negative 2 is negative 8. So we have negative 8 with an open dot, and then we got 3 with an open dot. X is greater than 3 in this direction. X is less than negative 1 or negative 8 in this direction. Alright, so our solution set would have to be negative infinity to negative 8, parentheses, because it's open dot, union, parentheses, 3 to infinity. Another way you could write your answer is x is less than negative 8 or x is greater than 3. Alright, so this is interval notation, this one's set notation. Alright, then for 26, same thing. We have to isolate the absolute value, so let's get rid of the 6. Since I'm dividing by 6, I could get rid of that by multiplying by 6 to both sides. Alright, so now let's make our two cases. We got 8x plus 4 is less than or equal to 6. Negative 8x minus 4, or 60, less than or equal to 60. Alright, so add or subtract the 4. We get 56. Alright, and then divide by 8. That should be x is less than or equal to 7. On this one, let's add 4, so we get 64. Divide by negative 8, which flips the sign. Alright, so we got 64 over negative 8, which is negative 8. So we got negative 8 with a closed dot, 7 with a closed dot. Everything less than 7 would be in this direction. Everything greater than negative 8 would be in this direction. So all the solutions fall in between. Alright, so in interval notation, this would just be bracket negative 8, 7, bracket. In set notation, this would be negative 8 is less than or equal to x, less than or equal to 7. Alright, so now let's look at transformations for quadratics. This is just transformations in domain and range. Alright, so for the transformations here, we're just going right 4. Alright, domain should still be negative infinity to infinity. And then you could graph this and see where the range would be if you wanted to. Alright, if you'll notice how there's no k value, so it didn't shift up or down. If the graph doesn't shift up or down, or it doesn't flip or have a reflection over the x or flip upside down, the range should always be from 0 to infinity. Alright, so here on 28, the transformation is just vertical compression by a half, domain negative infinity to infinity. Since the function didn't move up or down or didn't flip upside down, the range should still be 0 to infinity. You can see that on the graph. Now on this one, we went down 4. Alright, so this is going to change the range. Alright, the domain's still negative infinity to infinity, but now the range is going to be from negative 4 to infinity. Since we went down 4, here, we'll look at the graph. X squared minus 4. And we can see we went down 4, so negative 4 to infinity. Right, on this one we have a negative, so reflection, and left 4. Alright, so it's going to be upside down, so the range should start with negative infinity, and then there's no k value, so it didn't shift up or down, so 0, and then domain's always the same. And again, you could always just look at the graphs of these. Alright, 31, same thing, reflection, right, and then again there's no shift up or down, so the range doesn't really change. It's just, well, it does change because it's going to be upside down, so it starts at negative infinity and then 0 bracket. Alright, 32, we have vertical expansion by 3. We're going to go right 2. Right, here we don't move up or down, so the range would just be from bracket 0 to infinity. Right, on 33, vertical expansion by 2, domain negative infinity to infinity, range 0 to infinity, because again it doesn't shift up or down. Now this one we do shift up, right? So we go left 1 and up 4. So since we moved up 4, the range would start at positive 4 and then keeps going to infinity. So now on 35, change the following equations from standard form to vertex form. Identify the vertex of each parabola. Alright, so to find the new c value, it's c is over b over 2 squared. Alright, so I'm going to do this one 2 different ways. So one way that I do it is that I set it equal to 0. Move the c value, and I leave some space. So now let's find the new c value. So the new c value would have to be 6 divided by 2 squared. So that's 3 squared, which is 9. So I'm going to add a 9 to both sides. Factor this, which should be a perfect square trinomial. It's going to be x plus 3 squared equals 12 plus 9, which is 21, and then I'm going to move the 21 to the left side. Alright, so the vertex here would be negative 3, negative 21. Another way some of y'all might have been taught is this way: x squared minus 8x minus 10. Alright, leave some space. To find the new c value, we would take negative 8 over 2 squared. That's negative 4 squared, which is 16. Add 16, add 16. You could factor this. It's a perfect square trinomial. We would get x minus 4 squared. And then negative 10 plus 16, that would be 6. So the vertex here would be 4, 6. Alright, so these are just 2 different ways. You could use either method on any one. Now on the bottom, this is just multiplying, just foiling. So 2x times 3x, that's 6x squared. 2x plus 3, no, that's 5. So that's 10x. So 2x plus 5, then 7 times 3x, that's 21x. 7 times 5, that's 35. So this is 6x squared plus 32x. Oh wait, stretch that. 6x squared plus 31x plus 35. Right, then on 37, 2x minus 3y, 2x minus 3y. That's two of them because it's being squared. Right, so we got 4x squared minus 6xy minus 6xy again plus 9y squared. And then combine your like terms. Alright, so next one, number 38, same thing. Alright, so we got x times 2x squared, that's going to be 2x cubed. X times negative 3x, that's minus 3x squared. X times 5, that's going to be 5x. And then we got the negative 3 times 2x squared, that's going to be minus 6x squared. Negative 3 times negative 3x, that's going to be plus 9x. And then negative 3 times 5, that's minus 15. Alright, so combine your like terms. 2x cubed, that doesn't add up with anything, so just 2x cubed. Here we get minus 9x squared. Here we get plus 14x, and then minus 15. Alright, so now for the next page, 39 through 46, this is all factoring. Remember, always check for GCF first. So let's look at 39. We got 10a cubed b minus 12a squared b squared. Alright, so 10 and 12, we know that could be divided by 2. So GCF would be 2a squared b. Alright, so if I take out or divide this by 2a squared b, I'm left with 5a. This one I'm left with minus 6b. So that one, all I had was a GCF. Alright, so let's check the GCF on this one. Here we could take out just the 3, which leaves us with a squared minus 9b squared. Right, then this is a dots. These are two perfect squares separated with a minus. So we got 3 parentheses plus minus. Right, if I square root this, I get a. Here I get 3b and 3b. Right, so remember dots, it's two of them, one with a plus, one with a minus. Alright, then for 41, same thing, always check for GCF, 3, 21, 24, you can take out a 3, you get x squared plus 7x minus 8. And then let's factor this. All we have to do is find two numbers that multiply to negative 8, add up to 7. That would be positive 8 and negative 1. So my two factors here are x plus 8, x minus 1. And I didn't have to split the middle term because after I took out the 3, there's not a number in front of this x squared anymore. Alright, then on 42 there's no GCF, so let's split the middle term. Alright, so 12 times negative 6, that's negative 72. and then the middle term is negative 1. So two numbers that multiply to negative 72 add up to negative 1. That would be negative 9 and positive 8. All right, so let's split the middle term. Let's do, I'll do plus 8x minus 9x minus 6. Alright, so 12x squared plus 8x minus 9x minus 6. So we used the 8x and the negative 9x to split the middle term. On the left side, I could take out a GCF of 4x, which leaves us with 3x plus 2. On the right side, since it's leading with the negative, take the negative out with it. The GCF is a 3. If I divide these by negative 3, we get positive 3x plus 2. And so remember, these two have to be the same. If they're not, that means you did something wrong. And then whatever you took out, just combine them together. So one factor is 4x minus 3. The other one is 3x plus 2. And then on 43, this one they already kind of split the middle term for us, so we just have to take out a GCF from each side. So the GCF on this side would be 2a. Alright, so if I factor out a 2a, we're left with 2x plus 7y. On the right side, we could take out a negative 5, which leaves us with 2x plus 7y also. Or sorry, negative 5b. So take out a negative 5b. So negative 5b for the GCF. So then when I combine what I took out, we get 2a minus 5b, parentheses 2x plus 7y. Right, then for 44, here, since there's already an x, let's use a different variable. So let b equal x minus 2. So let's replace the x minus 2's with b's. So b squared plus 5b minus 6. Alright, let's factor this. Two numbers that multiply to negative 6 and add up to positive 5. That would be x plus 6, x minus 1. Or b. Sorry, we're using b. And then now replace the b back with x minus 2. So we got x minus 2 plus 6, x minus 2 minus 1. This gives us x plus 4, x minus 3. And so again, negative 6 and 5, 6 times negative 1 is negative 6. If I add them, I get positive 5. So those were my two factors. Now on 45, we have a dots. We have two perfect squares separated with a minus. Right, so they both start off with x. They both end with y minus 4. And that's it. On 46, we have a GCF of 3. And then what we have left on the inside, we could factor that using dots. Alright, so this one, or they both start off with x's, they both end with 5's. So 3x plus 5, x minus 5. Now for 47, it says find the quadratic equation that passes through these points. So for this one, I could just use len reg, so stat edit. We got negative 3, 0, 10 for my x's. For the y's, 92, 20, 170. Stat calc, len reg. Oh, sorry, it says quadratic. So quad reg. That's my bad. Quad reg. And there we go. Alright, so the equation here would be y equals, the a is 3x squared, The b is negative 15x, and then for the c, plus 20. And for this one, quad reg. Alright, then for number 48, if a tightrope walker falls, he will land on his safety net. His height, h, and feet after a fall can be modeled by the equation h of t equals negative 16 t squared plus 60, where t is the time in seconds. How many seconds will the tightrope walker fall before landing on a safety net, which is 11 feet above the ground? Alright, so let's find this one. So we're trying to find the time, and they gave us the height. It's 11. So since h is the height, we got 11 equals negative 16 t squared plus 60. Alright, so on this one, I think I could actually, or we can actually just use the calculator. Alright, so let's find Alright, so it's not showing 11 feet off the ground, which is the y. Alright, so let's try solving this. Alright, so we would subtract the 60. Alright, that's negative 49. So we got, let me write that over here, negative 49 equals negative 16 t squared divided by negative 16. It's like 3.0625 equals t squared. Then square root that. We get 1.75. Alright, so it'll take them about 1.75 seconds to reach the safety net. I think we could have done this. So this was the equation we typed in. Go to table set, and we could have done independent ask. So we were trying to find, okay, let's just check if 1.75 works. Yeah. So 1.75 seconds is when the height is about 11 feet. Alright, so now let's look at 49. So simplifying radicals. So first we got to take the negative 1 out, which square root of negative 1 is I. And then the 48 can be broken up with 16 and 3. So try to find the biggest perfect square to split the 48 with. So 16, alright, so 16 and 3. Alright, square root this, we get I times 4 square root of 3, so 4I square root of 3. Alright, square root of negative 81, that would just be 9I. Alright, square root of 81, we know that's 9, then that's I. Alright, this one, take out the negative, let's split the 80. So we could do, let's see, there's 4 and 20, let's see if we could do it with 16. Yep, so 16 and 5. Alright, so we got I times 4 times square root of 5, which cannot be square rooted, so this becomes 4I square root of 5. Alright, then the last page, solve by factoring. Alright, so let's factor this. And for this one, you could split the middle term or use mental math. Here, if you use mental math, you would start off with 3x and x. look for two numbers that multiply to 6, but then when you multiply the outside, multiply the inside, and add them, they should add up to negative 11. So let's see. 3 and we could do negative 3 and negative 2. Right, they both add up, multiply to 6. 3x squared, 3x and x make 3x squared. Here, if I do this, 3x and negative 3 make negative 9x. Negative 2 and x make negative 2x, which add up to negative 11x. So these are the two factors. Now set each one equal to 0. We get x equals 2/3, x equals positive 3. This one says solve by completing the square. Alright, so move the c value. The new c value would be negative 4 divided by 2 squared, which is just positive 4. Alright, so this is x minus 2 squared when you factor, and 15. Square root of 15. 15 cannot be broken up with a perfect square, so just leave it plus or minus square root of 15. And then just add the 2. So positive 2 plus or minus square root of 15. And then for 52, they want us to use the quadratic formula. So negative b plus or minus the square root, b squared minus 4ac over 2a. Alright, so here we have negative 4. Alright, so my a is 1, my b is 4, my c is 10. So we got negative 4 plus or minus 4 squared minus 4 times 1 times 10 all over 2 times 1. Alright, so let's find the discriminant. It's going to be negative 24, so we're going to have two imaginary solutions. Right, so let's split the negative, square root the negative 24. Alright, so we got this after we simplified the negative 24, square root of negative 24. Alright, now let's look at these three numbers right here. Right, they can be simplified by 2. So if we simplify those by 2, we end up with negative 2 plus or minus I square root of 6. Right, then for 53 through 56, it's finding the discriminant and getting the what kind of solution it would be. Alright, so this is just the discriminant, which is b squared minus 4ac. Alright, so let's find that discriminant. So negative 3 squared minus 4 times 2 times negative 1. That's 17. Alright, since the discriminant is 17, we would have two irrational solutions. Or two irrational roots. Alright, and then for the next one, we got negative 1 squared minus 4 times 3 times negative 4. Alright, that's 49. That's a perfect positive square, so this is going to be 2 real rational. Alright, so if it's a perfect positive, if it's a positive perfect square, it's going to be 2 real rational. If it's a positive number, it's 2 irrational. Alright, so not perfect square, perfect square. Now on the next one, we got negative 12 squared minus 4 times 1 times 36. That's 0. If you have 0 for the discriminant, that's 1 real rational solution. And then for the last one, negative 2 squared minus 4 times 5 times 6. That's negative 116, which is going to be complex or imaginary. And then for 57, this is going to be a solving one. Alright, so let's solve it by factoring. So we got x minus 2x plus 1 is less than 0 when you factor it. And so we got x minus 2, x plus 1 equals 0. And so our solutions would be x equals 2, x equals negative 1. Right, so it's less than, so that means if there's a parabola going through these 2 points, everything less than would be right here. So since everything is in between, the solution would be negative 1 less than x less than 2. And on this one, you could factor out an x, which leaves us with 2x minus 5. So we got x equals 0 for the solutions, x equals 5/2. Right, these are closed dots. And again, there's a parabola going through these 2 points, but the sign is greater than or equal to, so now we're looking at the branches. So this is above the line. Right, so this would be x is less than or equal to 0, or x is greater than or equal to 5/2. And then for the last one, solve the system below using your graphing calculator. So this one, just see where they intersect. X plus 6, x squared for the y2, graph them. They intersect twice. Just find where the y1, y2 are the same. So when x is negative 2, and what is the other one? Yeah, 3 and 9. Alright, so these are the solutions right here. Negative 2, 4, 3, and 9. So those would be the 2 points where they intersected. And that's the end of the review.